We can find the density of gas by remembering that calculating moles, we can use the mass and the molar volume. If we rearrange this equation, we get that moles are equal to the mass divided by the molar mass. We can substitute that in to our ideal gas equation and solve for grams divided by liters, which are the units of density for a gas. By solving for this, we get that our pressure is equal to the molar mass divided by RT. So what this says is that our density is directly proportional to the molar mass. As the density increases, as the molar mass increases, our density increases. As our molar mass decreases, the density of the gas decreases. Let's calculate the density of nitrogen. We're given a temperature and a pressure. So our pressure is in millimeters of mercury. We need to convert that into atmospheres. Remembering that 760 millimeters of mercury is 1 atmosphere. Gives us pressure of 0.99342 atmospheres. We also have to convert the temperature. So 125 degrees Celsius plus 273.15, and we get a temperature of 398 Kelvin. We now can use our density equation. MM stands for the molar mass, so pressure times molar mass divided by RT. So our pressure, we just calculated 0.99342 atmospheres. Our molar mass, we're told that it's nitrogen, so we have to take the mass of nitrogen, multiply it by 2 because it's a diatomic molecule. So we get 28.02 grams per mole divided by our ideal gas constant, 0.08206, atmospheres times liters divided by moles times Kelvin, times our temperature. And we find that our density of our gas is 0.852 grams per liter. So this is a fairly reasonable density. Gases are pretty low density. We use units of liters instead of milliliters because gases are very low density. Here's a practice. See if you can calculate the density of gas. Pause the video and try your calculation. We can start by finding the molar mass of our gas. Remember, the units are grams per mole. And so we're given grams of our gas. We can divide by the moles. And this gives us a density of 39.952 grams per mole. We also have to convert our pressure and our temperature. Oops. In this case, our units are torr. Remember, 760 torr is 1 atmosphere. We also have to convert our temperature. So we end up with 300 Kelvin. We can now use our density equation, which is the pressure times the molar mass divided by RT. So our pressure, 0.10197 atmospheres. Our calculated molar mass, divided by the ideal gas constant, times the temperature of our gas. We end up with a density of 1.654 grams per liter. Now there are other ways to solve these problems, so if you used a different method and came up with the same answer, that is perfectly fine.